So we will start as usual our lectures by reminder if there is any announcement. We remind you all that February 4th is the lab test one. It's weight 15% out of the total grades. And I'm emphasizing on this point at the beginning of the semester. You have 100 points in your bucket. The only missing part is 5 grades for the lab test 0. So still you have 95. It's your decision how much you're going to lose. Okay? So I wish good luck for all of you. And if you register on the section 1, please attend section 1. That's in the morning. I know it's challenging with this weather, but try your best to attend lecture 1 because your computer, your EECS account will be set up to receive or waiting for you in the lecture 1. In the lecture 2, all the people are registered on the lecture 2. The computer will be set up for them to do the lab test. Now, we're going to discuss, review what we discussed last time. We cover compare to and clone. This topic is included in the lab test. So we say that we create our own object. We need to use this object in the collections, or one time you need to sort these objects based on the ordering. It's good to override compare to. And to be able to override compare to, you have to implement a comparable interface. This interface contains only one method. It's called compare to. And we mentioned that in the header of the class. Say public class, you give the name that you would like to name the class, then implement comparable, and between the triangle bracket you give the name again, and inside your class body you insert your own implementation for compare to. And we mentioned last lectures about compare to contracts. There's some contracts, constraints we need to follow about to have a successful implementations. Once we implement compare to successfully, we can use our object on collections. Like we can sort our object, insert it inside list, or maybe tree, sort, list, whatever is the collection that you would like to put inside it, and you can use collection.sort. Because once you use collection.sort method, you're going to rely on compare to for sorting. Clone is another method whenever you decide to create a copy of your objects. And we discussed the shallow copy and deep copy. And today I'm going to also highlight few things about shallow copy and deep copy to make sure that you fully understand what is the meaning between these two copies. And also we mentioned last time that the clone method is not coming as a standalone as equal, for example, or toStrings. Also, we have to mention on the header of the class that we're going to implement a clonable interface. So clonable interface needs to be mentioned on the header, and we're going to include the clone implementation, our own clone implementations. What about today? We're going to continue discussing topics related to the Java. And today we're going to see mixing between static and non-statics and highlight the difference between what I mean by static fields and non-static field. We mentioned in the previous lectures about this. Today we're going to discuss this in details. And also we're going to bring out the concept of utility class. To remind ourselves about some terminology, so alias, what I mean by alias, is that you create an object, okay, and you give another name to another object. For example, most of us have his given name, and there is a nickname. So given name and nickname are both referring to the same person. So it's the same thing. You create an object inside your application or inside your program, and you give a name to it. Then you decide to change the name or give another name, but both names are referring to the same object. Here, for example, we created a list. This is the name inside our program. A list is a name, and this name referring to an object inside our memory, and this object of type array list, okay, and this belongs to the list interface. So this is an interface. List is an interface. We cannot create an object from interface. Actually, we use it as a reference type. A list, the name, and the object of type, the actual type is array list. Now this is array list of can store strings. So they can only contain string. And this is also an example of generic. We're going to cover generic later on this course. So this array list will store string. Now, while I'm working during the program, I need another name. I decided to use plist. Now, plist is also have the same declaration type. Declaration type is list. And also I say a list is equal to plist. So just simply now I have one object in the memory. Sometimes I give a name a list and b list. Both a list and b list referring to the same object. I'm not creating a new object of type array list. I create an object only once using a new. You see here a new operator. I create only one object, and I use a list and b list to refer to the same objects. Okay, I'm not wasting the memory. Okay, I just give different name for the same object. This is concept, we call it aliasing. Alias. Okay, aliasing. Keep that in your mind. Aliasing. Aliasing, that means you have the same object, but you give two different names. Okay. Yes, let's say this array list is stored in the memory at address 500. So a list will contain 500, and b list will also contain address 500. Okay, so the variable, what the value for the variable a list will be the address 500. What's the value for b list is also 500. Now the compiler will look what's the type is list, so it's referring to an object at address 500, and this object is array list object. Okay, so b list is an alias for the list a list. Okay, good? Agree? Let us proceed. Now, what's the shallow copy? We say that we don't create a new object, okay? But this is a shallow copy here. We inject a new definition here. It's more advanced than the definition we discussed last time. We're saying that a shallow copy of an object is a new object where the fields of the new object are alias of the field of the copied object, okay? So simply, you are now making more advanced and more generic definition for the shallow copy. We are saying that you're trying to copy this object. So all the object will be also alias for this object. You're not really creating a new object from that field. So you have an object. Inside this object, there is a field. You create a new object, but all the fields are alias. Okay, all the fields are alias for the copy object. Let us see complete this then we receive a questions. So the shallow copy of a collection is a new collection where all the element inside this collection is alias. Given that in the previous slide we discussed what I mean by alias. So all the thing inside it is alias. Let us look at this example. It will highlight a lot of things. So we have a new array list. This is an object because we create a new. We use a new to create an array list. Now look at the second line. We add a new string. We add another new string. Now we decide to create a new object, P. P is a new object now, but now what is the content of P? Nothing. B is a P list, is a new object, okay? That's why we say a shallow copy if an object is a new object. We did that. Right now, everything is okay. So we make it more advanced. A shallow copy is an object. Yes, it's a new array list. But all the elements inside P list will be actually alias from A list. Look at this. We go for loop for A list. Now we just add. We didn't create a new string when we add the string to the B list. So now we have array list, two array lists, but both an element inside the array list are shared between them. The picture here will make clear. So in this term, we can say P list is a shallow copy of A list. This figure will explain everything. I create A list and I create a string inside A list. Yes? Then I create another list. But look at the element. The elements are shared because the elements are aliases. This is the concept of shallow copy. Any question? No. Array list on a list, this is, let's say this is 500, this will might be 700, 800. But the element inside are shared. So if this element is at address 502, this again 502. Okay? And you can now take a string out and put whatever you like. Okay? You can take a string is an object. Okay? You can take a string out and you put whatever you like object. Your objects. In this case, you create two array lists, but the element inside these array lists are shared. That's what we call a shallow copy. Okay? Any question? Now, the deep copy is different. I think now you got some sense what is the difference between the shallow copy and the deep copy. In the deep copy is different. We are creating a new array list, and also for each element inside the array list A list, we create a new object. So we have independent. We separate them. There is nothing shared now anymore between array list, A list, and B list. Look at this. So we create array list. We add two elements. Now we go for loop for all the elements, and we use a new string. A new string is created for each element. Now, again, I'm repeating this. You have a string here as an example. You can take a string out, put whatever you like, any objects you like. You create, for example, a class for employee. You can replace a string by employee. So here, we are taking an element from array list. We create a new element, and we store it inside B list. The picture here will clarify everything. In this scenario, using this code, we say B list is a deep copy of A list. Look at this. So it's totally different. We separate them. There's nothing shared between A list and B list. Now, let's say you create your A list and you need to hide it. You don't need anyone to mess with it. So someone told you, please give me the list of your contact in your cell phone. You tell them, oh, I cannot share it with you. You might change number for someone. So you create a copy of it, an identical copy, deep copy, and you send it to him. So if he changes a copy in his Excel sheet, he will change it in his machine. You keep your Excel sheet without changing. Okay? The same thing. Okay? So you are creating an A list, and you create an element inside the array list, and also you create B list and a new element for it. So if the first element at address 502, the second element on the B list will be totally at different address. Yes, because in this slide, it's clarified that if someone go, for example, to A list, then go to the second element, right? Change it. Also, B list will see the change, because both are looking at the same object. Okay, good. No, there will be no sharing. If you are using deep copy, and that is the beauty of the deep copy. Okay. Yes, it will be changed on the A. The same thing, because also A list is also containing a reference where is the element is stored, and B list have an access to that element. And this is the dangerous. And I give you my own experience. One day I have my iPhone, and my wife got a new iPhone. What I did, I used a same Apple account for both. Then suddenly all my contact was in her list. Then she said, who is this guy? Then she started deleting the contacts. And then I received a phone without any name. Then I was surprised. I know, I registered your name. I don't know why. Then I figured out this problem. This is exactly was the shallow copy, because my phone and her phone was on the same. Then I create her own account and I will fix it. So that is exactly the shallow copy. Okay? You are sharing the thing. So both have the same right. A list and B list have the same right to modify the object, set the object, get the object, everything. Okay? So deep copy, no. You create a copy for all the fields. Okay, not only creating a new array list, but also inside the collections, all the elements inside the collection, you create a copy of it. Now, we're not having this problem with immutable objects and with the primitive type, okay? Because the primitive type are not objects. We have this problem of deep copy and shallow copy with objects, because objects, they are reference. And remember this and keep it in your mind, Java always use a reference pass by value. Pass by value for both, for the object and the primitive type. Okay? So now, today we will start our new topic. It's mixing static and non-static. Then you break this, but these are two strings. Both will have the same memory address. Whenever you change the reference on P, will change on A. You cannot say, I want to keep shallow copy for 5 elements, then the second 5 I will remove it. No. You either to have the shallow copy, that means, in the case of the shallow copy, that is the aliasing. Aliasing, that means you have one object in the memory, two things are pointing to the same object. That is the aliasing. Shallow copy is doing aliasing. If you break that, then you don't have aliasing, then you don't have a shallow copy. Okay? So most of the time, while you are working with the Java and you create your own application, you will mix things together. You will have a static fields and you will have non-static fields. Let us dig deep and see what the difference between the static fields and non-static fields. So a fields that are static is actually bare class, and we call them static fields or a class variable. So these are not bare objects. It's bare class. Okay? It's bare a class, not bare objects. So only one could be, and that is the beauty of the static fields. It's only one could be bare all the objects in this belong to this class. Okay? You define a class called car, and you define a number of wheel is equal to 4. So all the objects that you are creating from this car class will have number of wheel is equal to 4. Every object is created from the class have the same copy. So the value for this field is fixed for all the objects inside the class. The static field are, you define it only once you see that the class that you are defining has some common value, common state. For all the other objects, they will have the same state. For example, you can if you define, that's a mistake, if you define a class student and you define a GPA as a static, then all the students, they have the same GPA, which is a problem. Okay? So that's why the GPA should be, for each student is different. But yes, it's a common attribute, but this is not a static, because each object, each student has his own GPA. We cannot make a GPA as a static, because otherwise all the students will have the common GPA and fixed. So it's actually, we're not using a static fields very frequently, only in case if we have really a common value for all the objects. Example, let's say you have a manufacturer that is producing bicycles, and this manufacturer would like to keep track number of bicycles produced by the factory. So it's a good idea to have a static field for that, and also we can use this static field to give an ID, a unique number for each bicycle we created. So we have a common static field is the number of bicycles created by this factory, and also we have instance variables, we call it, because it's each object has its own, could be like a GPA for each student has his own GPA, we call it instance variable. We have an ID for each bicycle. ID is unique, but the number of bicycles is common for all the bicycles produced by the factory. So we can answer this question, how many bicycles or how many objects we create them, and such field is not related to any individual object, because these are related to the factory. So let us see how we can implement this. So we have a class called bicycles. Inside this class we define the fields, And one important field is called a private static int number of bicycle is equal to 0. So we initialize the static fields to be equal to 0, and we define it as a private. Nobody can access this outside this class. Only the method inside this class can access the private field. So it's a static. That means each copy or each object from this class bicycle will have the same copy. The same copy. Now we have the constructor, and we know that the constructor is responsible to create an object. So it's better to increment the static field inside the constructor, because to create an object from the bicycle, you need to call the constructors. Okay? Now, we access the static field without any object. So we can access the static field by the class name. As you can see here, we have bicycle dot. So bicycle is the class name. So we go bicycle dot, we give the name of the static field. We don't need an object to access the static field. So we can access the static field by using the class name. And we increment the number of bicycle. And as you can see, we can create an object from bicycle using the constructor. That's why we go to the constructor and increment the static fields. Now, it's very important to also to notice that we are not using this. Why are we not using this? Can anyone suggest? No. No, but this is the default constructors. That's right. Always we said that this is pointing to an object that is being initialized. When you say bicycle dot number of bicycle, you're not having an object in your hand right now. Static field is belonging to the class. It's not belonging to any object. So this is pointing to the object. So we can access the static field without this, not this. We're not using this with the static field. Be careful. No, not because of that, because it's defined as a static. We cannot use this because it's defined as a static, not because it's defined as private. Okay? Private is related to how we can access it from outside. The client can access this field or not. When we say it's a private field, that means it's only accessible by the method inside this class. The client cannot directly access this field. No, it will create a confusing. So whenever you have the static field, it's good to use bicycle dot number of bicycles. You can try an example, okay, by your own, write down and write it without bicycle and see, because that will be local variable, global variable, and all of this, the scope of the variable. Okay, you try it and see what the result. So, and also we have method. This method to retain the number of bicycles. You see this method has something on the header. What's the header is saying? Public. That means it can access by the client. The client who are using the bicycle class can use this method. And this method is also static. Int, retain type, get number of bicycles, there's no argument, and is only retain, again, bicycle dot number of bicycles. Now, it's very important to see that the static field and the static methods. Only a static method can access a static field. Okay? To access the static field, you need a static method. Okay? You cannot access the static field with method that is not defined as a static. Okay? So, yes. Where there? Here? Yes, because we need the number of bicycles. You have this class, you have the factory, it's creating a bicycles. Need to count the number of bicycles that you are creating. You need all the objects to share this value, to know the number of bicycles. And to use this fact, the number of bicycles, to give an ID for each bicycle, unique ID. For example, this is a bicycle number 1, this is bicycle number 2, this is now bicycle number 3. To be able to give this ID to the bicycle, you need to know the number of bicycles you so far is created. Okay, so we create a private static int number of bicycle, and we keep increment this field whenever we create a new object. Yeah, but how are you going to share the copy between all the objects? Each object has his own state. You create a bicycle number 1, you will have a number there. And you create bicycle 2, it's independent. They don't have anything shared between them. No, but they are not looking. They don't know have any information shared between them. No, we're not creating a new static. It's only one static, one field, one copy. One memory will contain only one copy for this field. Yes, even if you create a new bicycles, they will share the same copy. All of them, they look at the same place. Okay? So that is the beauty of the static. It's all the object, then you're not copying it every time. There is only one space, one place on the memory, everybody is looking at it. So number of bicycle is one field, bear a class. That's why we access it without object. We access it with the name of the class. Okay? We keep increment. Every time we create an object, all the objects share the same copy, share the same value. So now, as you can, what happened if we made the number of bicycle non-static? And that is back to your questions. What happened if we have number of bicycle non-static? That means all the object has their own copy of bicycles. Okay? So every bicycle, think that has a different number of bicycles. So each object will have different copy of the static field. So in that case, there will be no awareness how many number of bicycles we create so far. And now, each object will have his own state, independent from the second object. The method need to be static because only a static method can access static variables. Public class, public bicycle, no, this is a constructor can access. Constructor has specific functionality and behavior. It's allow you to create an object and they can access the static without using a static on the declaration. Okay? Only the method. Methods to access the static variable needed to be a static, but the constructor no. Okay? There is also, if you remember, we discussed the static initialization. Okay? We discussed a static initialization. That is an initialization bear a class. Okay? You can go back to the previous lectures and read more about it. So this time, for example, if you are interested how many times you call method, a specific method, let's say, you are interested how many times you call and that's happened sometimes on the marketing. You want to see how much user click on this one or this one. So each click is being execute some kind of methods. So it's good to keep track how many times you call this method. For example, here we define number of time X method is called and number of time Y method is called, and these are static. And now you can see here we are using the class X and by the name. And here is very important that this class, this method is accessing the static field and increment it whenever we call the method X. Again, whenever we call the method Y, we increment. So we can count the number of times we call these methods. Now, it's good and useful, for example, in the example we discussed on the previous lectures, point 2, to add public, static, final, point 2, origin, and we define the origin. So we define this as static. That means all the points that we create from point 2 class will share the same origin. Okay? And also we mention in the declaration it's final. That means nobody can change it. Once we initialize it, nobody can change this point. Now, mixing static and non-static. So normally when you declare the class, you will have non-static fields, and that is the field is pair and objects. So if you, again back to the example, if you decide to give a unique serial number for the bicycles, you need using the static variable, so you can do that. So in this case, we define a private integer serial number, and this serial number is for each bicycle we create, we will have a unique serial number. And we define the number of bicycles still as static. How do we assign for each bicycle a unique bicycle serial number? We can use the static field to help us and guide in assigning the unique number. So you can see, this is the example. You can see here, inside the bicycle constructors, we will have this dot serial number. And this dot serial indicate that we are accessing the object is being initialized, and the serial number is equal to what? Bicycle dot number of bicycle. And look here, bicycle dot number of bicycle is the static. It's common bear all the bicycle that so far you create in your application, and you assign that to the serial number. Serial number is a pair object. For each bicycle you create, you will have a unique serial number. You use the static as a help for you and guide to give a serial number. So if, for example, the first bicycle you create, it will have a serial number 0. The second one will have 1, third, fourth, and you will keep doing like this, and you guarantee that each bicycle you create has a unique serial number because you rely on the static field. And this number of bicycle, there is only one could be their class. And it's good to notice the difference between accessing the non-static field and static field. For the static field, we use the name of the class dot bicycle dot number of bicycles. For the non-static field, we use this dot serial number. Any question? Yes, it's non-static. Serial number is non-static. Yes, if the serial number is static, we cannot use this. Now, you can decide to use a new serial generator, which is you need to implement this class. Sometimes you need to define a random number and use the serial generator. And whenever you ask for a next serial number, it will check all the previous numbers generated and will generate a new one, and you can use that. And this, as you can see, the serial generator is defined as a static. So that means all the objects in this class will share the same generation numbers. So whenever it's called the generation serial number, you will call the same generation number, will check all the previous history, what's the previous number is generated, and will generate a new number for you. Now, constant field normally are defined as a static. So if you have a constant like what we saw in the previous slides, like an origin, is a constant for all point of 2 dimensions. So if you have a point in 2 dimensions, the origin is fixed, 0, 0. So it's good to define the constant per class as a static. So all the objects in this class will share the same constant. Number of wheels, as I mentioned, if you have a bicycles, number of wheels for the bicycle is a static and fixed for all the bicycles you are creating on your application. So also it's good to have them as a public, not as a private. Okay, if you are defining a constant like pi in the math, pi is a constant. You define it as a static, and it's fixed for all the math calculations, and it's public. Everybody can access this constant. And it's good to make it final. That means nobody can change it because it's a static, final, and public. So normally constants have this public, static, final when you have constant in your application. Now, we use a static with the variable, and we call with the fields, and we call them a static fields, class, variable. Okay, we can access them by the name of the class, and also we can use a static with the method. And in this case, that means all the objects, they have the same copy of these methods, and we can access this method using the class name. We don't need to create an object to use this method. So that is a good thing about the static method. You can use the static methods without creating object, and that makes sense. If the static methods can access only a static fields, because you can use the static method without an object, and the only thing you can access is the static fields, because static field you can have them without an object. So keep that in mind. If you have a static method, you can access only a static field, because static fields are accessible without an object, and you can access the static method without an object. The client can call the static method by using the name of the class, like math.cosine, math.sine. You can use the sine method, cosine method. You can use the sine and cosine, and you give any value, and will retain the result for you without creating an object from the math class. Okay? And there is only one copy of the static methods, and it's shared between all the objects. And this is the one that I always emphasize about it, is static method can use only a static method can use only a static fields. A static method, there is no this inside the body of the static method. So avoid using this, and whenever you see this, immediately this is a compilation error. We cannot use this, because this is a special keyword pointing to the object that is being initialized. That means you are saying that I need to use an object inside a static method, and this is not valid. Okay. And remember this, inside the class method, inside the static method, you cannot use this or super. And we're going to come to super later on when we discuss inheritance. So always the body of the static method can access the static fields. You cannot use this. You cannot use super inside the static, because whenever you decide to use this, you are saying I need to access an object. Whenever you decide to use super, you say that I need to use the super object. Okay, so that's why we are not allow any this or super inside the static method. Okay, non-static method can use all the fields. So if you have a non-static method, that is method like defined without a static keyword, it can access a static and non-static field. You have all the freedom to access the static and non-static. And this is an example of the constructors. Constructor is non-static method, but it has a special, allow me to say that. A constructor is not a method. A constructor has a special purpose inside the class, is to create an object in the proper state. So any non-static method can access a static field and non-static field. There's no restriction on non-static methods. So you make the method static if the body does not refer to any field or a method in the object. So whenever you decide to have a method that is not referring to any instance fields, then you can make it static. let us see here. This is an example where we have a get number of bicycles created. We retain bicycle.number of bicycles. This is a static method, can only access a static field. And get serial number, this is non-static method. And also set a new serial number by saying this dot serial numbers equal bicycle serial generator dot next. So this is both are non-static, they can access and use non-static field and static field. Okay, so this is an example whereas you have a static method can access only static field and non-static method can access both. Now we come after we discuss the static and non-static field, static and non-static method, we come to the one main methods. We call it a static factory methods. Why we call it a static factory method? This is a static method in non-utility class. The purpose of the factory method is to create an object and ship it back to the client. So inside this method, factory method, whenever you come across factory methods, you gonna see inside the body that you are creating an object and you retain an object to the client. So you're not retaining any primitive value, you retain an object to the client. So let us see an example on this. So a static factory method is a method that can create an instance of the class and ship it back to the client. So it's make an object and retain a reference to that object. So normally we use a static with the factory because it can access with the class name. We don't need an object to access the static. Unlike the constructors, you can give a name to this factory method. So if the purpose of the factory method is to create an object, and I know the purpose of the constructor is to create an object, so there might be overlap. No, there is a difference between these two things. The constructor is creating an object that you are trying to create from the class, but the factory method normally are static, and you give a name, different name for the factory method. They can differ, not just the name of the class. You can name it whatever you like, and inside the factory method, you create an object and you ship it back to the client. We can see some example will help us to understand what the difference. Here is the example where you have the point x and y, and you would like to take the point x and y and retain the polar coordinate r cosine theta, r sine theta, where the theta is the angle between x-axis and r is the magnitude of the vector. So you have the point x and y, and you need to retain the point in polar coordinate. How we can do this? Let us see. So we have x and y, and inside the point we have the constructors that receive two arguments, x and y. We initialize x and y. Now we have another constructors. Okay, that is the one purpose. So we rely on the constructor to create. This is not a good way, because now x and y is a Cartesian coordinate. Okay, now I take r and theta and I calculate x and y using r and theta. Okay, so I receive r and theta, and I use r dot math dot cosine theta plus r dot math dot sine theta. So I use the sine to calculate the and cosine, and then I calculate x and y. So this is illegal overloading, because constructors have the same signature. Yes? We cannot do this. You can see here there's two constructors, and this constructor are the same. So this is illegal overloading for the constructor. We cannot do this. How we can solve this problem? We can use a static factory methods that allow us to create an object and ship it back to the client. So we have the same constructors, point 2, x and y. We create them. Now look here, we have the polar method, the name of the method. This is a static factory method, and look at the retain type is 0.2. So I receive r and theta, and then I calculate x, I calculate y, and I retain a new 0.2. So I create an object of 0.2, and I retain a reference to the client for that. I'm not using the constructor, so once I receive r and theta, no. I use the static factory method to solve the problem. I cannot do overloading for the constructor with the same signature. You can see how the static factory method help us to solve this problem. Any question? Okay. So there is a lot of static factory method we come across over without noticing this. Like on the math long integer, we have public static integer value of, and you give int value and will retain what? Int integer as a type. And also we have array. You can use a copy of array. For example, you have created an original array of 5 elements, and you decide to extend the length. The only way to extend the array length is to create a new array with a larger length. So that's why we use a copy of. You give the original array list and you give a new length. It will create a new array and ship it back to you. So that is another example of the static method. Also we have a string. A string is filled with this kind of factory, 2 lower, 2 uppers, all of these give me part of the string. All of this format, for example here, you give a format string and you give some arguments and will retain a new string for you. So actually factory method is not a new. We come across over it very frequent on while Java, but today we highlight what is the purpose of the factory method, and normally the factory method are defined as a static, so they can access by the class name. I don't need to create an object from array to create a new array. Okay? Just to summarize some more, some useful information about the static. When we use the static with the variable, that means this variable belongs to the class. Only one copy of the variable. We can initialize this variable only once. If you have a static fields, you can initialize it only once at the execution. The variable will be initialized only once before the initializing of any instance variables. And there is a single copy of this static variable shared between all the objects of this class. Normally we can access the static variable by using the name of the class dot the name of the variable. If you decide to use the static with the method, then you have the method that is belong to the class, not belong to the object. You can access this method using the class name. And the only accessible field for a static method are static fields. So you cannot access non-static fields. Okay? You can call any other, a static can call only other static methods and cannot call non-static method. And that is back to the fact. If the static method call only a static field, so a static method can call only other static method. Okay? Everybody understand this? Any question? Okay. So we cannot use this or super inside the body of the static method. So if you have a static method, you cannot use this or super inside it. You can access the static method using the name of the class dot the name of the method, and you send whatever argument you need to the static method. Any question? Okay, so as we discussed on the previous slides, that static fields and static methods are per class. So we need some tools to do the task. You have the construction worker. Normally, the construction worker has some tool set or toolkits, and he used this tool set to do some job. Okay? So the same thing in the math utility class. You need only to calculate the cosine or sine of the angle. You have the angle, but you need to calculate the sine and cosine of this angle. I don't need to create an object of the math. The only thing I need to use cosine and sine method. So we define sine and cosine as a static. Using all this together to build what we call a utility class. So what is the utility class? It's a utility class. It's shipped to the client, so the client can use this utility class without creating an object from it. Okay? So the utility class, it's very useful on the application. Okay? And many times when you program any application in your life, you think that I need a utility class. I need the utility functions. Okay? I need the functions that can read the map and calculate the average. I don't need to create an object from the class to do the average. So I need just to I send the array, I need to calculate the average. I send the array, I need to calculate the standard deviation, for example. So in all our life, we are using this kind of utility class, but in different aspects. Okay? So that is the thing. That is the utility class. So we're going to put all the previous knowledge all together to see how we can create a utility class and allow the user to use this functionality of this class without creating an object from this class. And even we have to prevent the client from creating an object from this class. So it's more like things or a concept. That is the class, yes? Whenever you go to the Java, you have a concept or a things in your mind. You need to create a class. Oh, I need to create a class of laptops. I need to create a class of the chair. I need to create a class of a student, an employee, a manager. So you have this kind of object-oriented concept. The class is simply like a blueprint for creating an object. So you are creating, let's say, I create the exam papers, then I put it in the photocopy to create a copy of it. Okay? So it's just only I create a class of employee, then I create many employee. I create a class of a student, then I start creating many students objects from this class. It's like a blueprint. Is that something is fixed, and then you copy it every time you create an object. And we have a field that represents the structures, because the fields contain the state, okay, of this object. And whenever I ask, what is the employee number? You give me the employee number, okay? The state of this employee, the name of the employee, okay? The same thing. So the field is holding the values, okay? And this field could be object, could be a repetitive type, whatever is it. So the field is holding the data or the information that we need. The method is doing some kind of behavior, okay? Calculate the salary for this employee, calculate the GPA for this student. So it's more like something we have to do with some data stored inside these fields. Yeah. So we have the field that can store the data, and we have some kind of method that can process these data. Okay? Let's just summarize. So utility class that is not used to create an object. So always keep that in your mind. So whenever we need to use a utility class, we are creating a class that we cannot create an object from this class. Now, such a class has no constructor for the client to create an object. So there is no constructor inside these classes. All the features inside the utility class are static. And I believe all of you understand what we mean by static fields. When we have all the fields are static, that means most of the time all the methods are statics. Okay? Now, there is a lot of example of utility class in our Java, and we are using them maybe directly or indirectly, like math, array, collections. All of these are utility class. We don't need to create an array of objects to use the method inside the utility class arrays. So the purpose of utility class is to group together a related field and the related methods to create an object. It's not necessary to create an object. So you have some related data, some related methods, all together, you group them together inside the utility class. You no need to create an object. You calculate the math, calculate all the informations, all the data, all the fields that is related to the math, like the define by, define 0, whatever is it, and then all the behavior, cosine, sine, square root, power of functions, okay, all of these methods inside the math. Arrays, calculate all the fields that is needed for the arrays to manipulate array, and also all the methods that is related to manipulate the array. Okay, we don't need to create an object from this utility class. Again, this is we discussed this. This is a math class. We don't need an object to calculate the cosine of the number. Your array, let's make it easy to perform all the manipulation of array. You can create a new array from a previous array. Okay, search inside the array. You don't need to create an object to search inside the array to calculate the average of the array. Filling the array with some value also. We have the collections. We're going to come across the collection methods and discuss more details later on this class and this course. So it's a group all the related method that is processed on the collections. Okay, retain the size of the collections, do some searching, sorting the collections, all of that. Okay, this is a good question. Whatever you need inside the lab test or even inside the lab, it's already important for you. Okay, so it's not necessary, and it's not even, it's going to give us a compile error later on, because we give you the Java that contains all the necessary import. So if you decide to use out of that, it's really a problem, especially for the lab test. Okay, so we have to stay within the given information inside the lab test, 1, 2, or 3. So if we need to use the collection to solve this question on the lab test, I will do it for you. You will find me import this for you. Okay. Now, what's the difference between the class, the normal class that contains static and non-static fields, between the utility class? The class, you can create an object, and once you create an object, you have his own state. So you create an employee, you have an employee number, different from each employee. You have a name for each employee, is different. They don't have the same name. Okay. For example, inside the Java, you have the Java, this is the class called point, which is for the graphics, and you can create x and y, and you give a value for x, and you give a value for y is different from the second point. So here, example, you create 3 points, okay, 0, 17, 100, -1, and 5. So you create these points in your code. So each point has its own status value for that. Now, each object will have some location on the memory. Okay, so whenever you are using a new, keep that in your mind. You are reserving some space on the memory. Here is an example of the memory layout. It might be look like this. It's some assumption that point class at address 100. We load the class. We bring the class from the file. We load it to the memory at address 100. Okay. And we create a new point 00, and we store it at address 200, and at address 300 we store the second point, and at address 400 we store the third point. So this is just like an example of what is the layout of the memory. Continue in the next slide. Inside our application, the main method is loaded on the memory at address 500. Inside it we have P, Q, and R. These P, Q, and R are variable, are created on the main method. And the value for this variable is 200A, that means is the address 200. And what is exist on address 200 is the origin point. Look at the method here. P is equal to new point 00. So we create the point in the memory at address 200, and we store address 200 on the P. So whenever I go to the address 200, I find the object X and Y and retrieve it. Then P, what's the type of P? Declare type is point. So I know from the compiler that the object is stored at address 200 is a point object. Okay. Now, utility class is never used to create an object. Normally, whenever we decide to make a class as utility class, we group some fields, some methods that are related to each other, and there is no need to create an object from utility class to use it. So this is a clear example. We don't need to create a math object to use cosine and sine. Even I don't need to create a math object to use pi. Pi is a constant for all the math. Okay? So I'm using the same pi for all the calculation. Is a static and is a single copy for all the objects. This is the layout of the memory whenever you are using a utility class. Math class is loaded on the memory at address 100, and pi it's loaded with the value, and E is loaded with the value. So you have only one copy, and it's shared between everybody on your applications. In the main, you have x and y. You calculate the cosine and sine of pi over 3. Okay? A simple utility class, if someone asks you to calculate the Einstein famous mass energy equivalence equations, that's E is equal to mc squared. What is E? E is the energy, c is the speed of the light, m is the mass in kilogram. So this is an equations. You need to calculate these equations. You can create and implement a utility class to do this for us. Let us take this example and step by step together to implement this Einstein formula. So first, I declare the package that this class will contain inside the package ca.yorku.ecs2030. So this package implicitly inform me that I will have CA folder. Inside it, there is a YorkU folder. Inside it, there is EECS folder. Inside it, there is another folder, EECS2030. Inside that folder, there is a file named relativity.java. Inside that Java, this is the definition. We define the speed of the light as a constant. And as you can see, because we say if we have a constant per class, it's good to have it public, static, and final. So we have public, static, final, double, and we give the speed of light. Then we have this method. This method is a static. It's called mass energy. We provide the mass, and inside this method, we calculate the energy and retain the value. It's really the mass times the relativity.c, because C is a static, so we can access it by the name of the class. We don't need the object to access C. Relativity.c times relativity.c times the mass will retain the energy. Okay. Now, inside the main method, okay, this is how we can use the utility class on the client side. Again, 1 gram. The class is called 1 gram, and it's included in the same package. We give the mass 0.001. Now, we ask relativity.mass energy. Mass energy is a static, so we don't need an object to use this method, yes? Because it's a static method. We can use it by the name of the class. So we can use relativity to the mass, and we send the mass, and we will receive back the energy. Now, the field, we define them as a static. That means all the member will have the same value, and they are constant. You can see the modifier. Access is public. Everybody can access it. It's a static modifier, and it's a final. No one can change it. And it's type of double, and the name is C. The value is the light speed. So the name must be unique per class. The scope of the field is entire class. And if you go to the textbook, that one on the Moodle, normally they give the term only for the public fields. They use public field. But we already set up this on the lecture number 1. What do we mean by field? What attributes? Okay, all of these information. Now, public. No, no, I just highlight this. Only the static fields are bare class. Non-static fields are called instance variable. Okay, I just highlight this to whenever you go to the textbook on the Moodle, the textbook, don't get confused because he used different terms. Okay, but for our class, you look at the lectures, what the term that we have used, you have to stay with that term. So we are using class variable for a static. Okay, a class method for a static class method. Okay, and instance field, we use this instance field for non-static field. Okay, so we can access these relativity.c. We can access it directly because it's public. Now the field is static. That means it's per class, only one copy of the class. This slide is repeating what we discussed actually, but make it more documented. So whenever you go back to the slides later on, you can find this information. And every object is created from this class, declare the static field, and share the same copy. And that is the one that I always mention, that sometimes they got confusing. Static variables, the textbook is using, we are using class variables, okay, which commonly used as class variable. Class variable is the same as static fields, is the same as static variables, okay. Now, there is an issue in the class that we have created, but I will highlight it later on. Here we are using relativity y, relativity z, new relativity, new relativity. So remember, relativity is a utility class, but now let us assume, according to the definition that we have, we can create an object. We didn't prevent the client from creating an object because Java provides us with the default constructor, no argument constructor. We didn't prevent the client. So the client went through and create two objects, relativity y and relativity z. How the memory layout will be to see but just the impact of the static fields. So we call y, and we have a relativity class load in the memory at address 400, and we have the value for z. C is belong to the class. So only one copy of C, and we define relativity for y, and that is at address 1000. And also we have a relativity z at address 1100. And look here, no copy for C inside them. The C is only one copy in the memory. So y and z, they are both share the same copy of a static field, okay, or a class variable if you want to call it. So we create a new object from utility class, which is against the rule, and we allow the user to do that because in our definition for the class we didn't provide a private constructors. We allow the client to create it. Even we didn't mention anything about the constructor in previous slides. So the Java inject the default constructor for us on the definition, and the client was able to create an object from our utility class, and we have only one shared copy. So we can calculate. So the static attributes illegal, it's illegal, but is considered bad form to have public static attribute based on the objects, as we saw in this example. So C dot so it's good to have final, so the client cannot change it if you want to make it public. So public static final is intended for a constant value inside your application. Now, this is a relativity, and the field is a primitive type, and it's final. Now, if someone in the main access C and try to change it, will not be able to change C because C is a constant now. Okay, so C is now public static final, so will not combine the field C is final, and it's already previously assigned in your application. Now, there is a final. It's good for a mutable. In this case, we have final string x, and we assign the value for it. And this will not be compiled because x is final. Okay, and the string is immutable object. No method can modify. But this is a very important slide where it's highlight that whenever you declare final with an object, you should be careful because the final is a reference, not the object state. We discussed this in the previous slide on the last, not like before the last lectures when we discussed final. So this is a fraction. We define a new fraction, 1/2. And we say this is a final fraction half. The only final here is the half itself, the value inside the memory, but not the state, 1 or 2. So if the client go through and set denominator to 3, this is legal, it's work. So final with fraction here, and we give a set operator to the client so they can access final and change the state of that denominator has become 1/3. You have to be careful. See in the previous slide, we have immutable object. We are not worried. We are worry free. We don't worry that even the client will not be able to change immutable objects like a string because we create a class, immutable class. So if you want to share the constant and final with the client, make sure this client, there is no set operator as you see in this example, or this is a mutable object. So this client that cannot change it. You can see this is a memory map for the example. The only final here is this value, 700. This is the final thing. But this value is not final. When we say final half, 700 is final. You fix that. But 1 and 2 are not final. And you can take fraction and put any object you like. You final employee and you give set employee name. They can change the name. The only final here is 700. That is the only final. Okay, just to continue this. Okay. So to finalize this topic before we go, this is the final field, is a mutable type. Public is very important to keep that in your mind. Whenever you share a mutable type as a final, it's not actually final. Okay? And we will continue next lecture about how we can avoid using new relativity, because currently relativity is a utility class and the client can create an object from utility class which is against the rule. Okay? See you next lecture.